In the stillness of a Swiss observatory on a moonless night in 1933, Fritz Zwicky adjusted the telescope with a quiet determination. The cold air bit at his fingers, but he paid it no mind. He had spent months studying the Coma Cluster, a glittering collection of galaxies suspended in the vast expanse of space, and tonight he hoped to make sense of an anomaly that had gnawed at him for weeks. The galaxies, each a swirling island of stars, glided gracefully within their cosmic sea. But something was wrong. Their motions defied the known laws of gravity. They were moving too fast, as if invisible hands were tugging at them, guiding them, protecting them from flying apart. Zwicky frowned, running calculations in the dim light. If only the visible mass, the stars and gas, were accounted for, the galaxies should be tearing themselves apart. He stepped back from the eyepiece and muttered in his native German, "Dunkle Materie," dark matter. It was a name born not of understanding, but of absence. A placeholder for a mystery he couldn't yet unravel. Decades later, in the deserts of Chile, Vera Rubin stood under a dazzling sky peppered with constellations. The hum of her spectrometer accompanied her thoughts as she prepared to measure the rotation curves of distant galaxies. While Zwicky had glimpsed the footprints of dark matter, Rubin aimed to chart its dance. The first galaxy she studied spun like a child's toy top. But as she charted the speed of its outer stars, her data startled her. Those stars, far from the galaxy's luminous center, were moving faster than Newton's laws would predict. It was as if the galaxy were cradled in an unseen halo, a cocoon of invisible matter that defied gravity as she understood it. Star after star, galaxy after galaxy, Rubin's work painted the same picture. The universe was haunted by something vast, powerful, and silent. She turned to a colleague and whispered, "We're swimming in shadows." Imagine, if you will, a night sky filled with stars. Yet for every point of light, there is an expanse of darkness so profound it defies comprehension. This is dark matter, a presence we cannot see, touch, or hold. It neither emits nor absorbs light, remaining forever cloaked from our eyes. And yet, it is everywhere. It bends the paths of light from distant stars, warping space like an unseen puppeteer. It shapes the scaffolding of the cosmos, guiding galaxies into their forms and holding them fast against the pull of their own chaotic movements. Physicists today describe dark matter as the missing mass of the universe. Without it, our galaxies would scatter like leaves in a storm. It comprises more than 80% of all matter, yet its true nature remains hidden. Is it made of weakly interacting particles, slipping ghost-like through the fabric of space? Or is it something stranger still, a relic of dimensions beyond our grasp? Dark matter reminds us of the limits of our understanding, of the boundaries where light fades and shadows take hold. It is a contradiction, the invisible force shaping the visible universe. Some scientists wonder if we are looking in the wrong place, chasing particles when the answer lies in the fabric of gravity itself. Others argue that dark matter may be the key to solving some of the universe's greatest mysteries, from the nature of black holes to the birth of the cosmos itself. As we look out into the night sky, we are reminded of a profound truth. The universe is not defined by what we see, but by what remains hidden. Zwicky and Rubin glimpsed these shadows, and generations of scientists after them continue the chase. Perhaps one day, the dark will speak. For now, we live in wonder. What is dark matter? And in a universe ruled by the unseen, how much more is there that we have yet to discover? The stars do not shine alone. They dance in the embrace of something deeper, something darker, something that reminds us how little we truly know.